Hello students, today we will see the second topic from your mathematics part 1 book, that is real numbers. We have studied the groups of numbers such as natural numbers, whole numbers, integers, rational number, irrational numbers and real numbers. So within that, real numbers means rational and irrational numbers together known as real numbers. Real number is like a universal set. It contains all numbers such as natural numbers, whole numbers, integers, then rational numbers and irrational numbers also. Okay. Natural numbers, you know it very well. Natural number starts from 1, 1, 2, 3, 4 and so on. Whole numbers means 0 and all the natural numbers. Then next to that is integers. All positive numbers 0 and negative numbers known as integers. Then rational numbers. Rational numbers means the numbers which is in the form m upon n and n should not be 0. These numbers means these numbers are in the fraction form. Next to that is irrational numbers. Irrational numbers means mostly the numbers which are not the perfect squares. Means root 2, root 3, root 5. These numbers are known as the irrational numbers. Now the group of rational and irrational numbers is known as the group of real numbers. We are denoting the natural numbers by capital letter N, whole numbers by W, integers by I, rational numbers by Q, irrational numbers by Q dash and real numbers by capital R. Now in this topic we will study properties of rational numbers, then properties of irrational numbers, surds, comparison of quadratic surds, operation of quadratic surds and rationalization of quadratic surds. Now here also if you will see, let us recall whatever information now I given to you, same information they given here. Just only one point remain to tell. N is subset of W, is subset of I, is subset of Q, is subset of R. I said to you, R means real number set is like a universal set. Now next, ordered relation on rational numbers. You know very well what is meant by the order relation. Order relation means just comparison, like this way. These signs we are using for the order relation. Now here they had taken the rational numbers such as P upon Q and R upon S are rational numbers where Q is greater than 0 and S is greater than 0. Means the denominator it should not be 0. Now first they given here, if P into S is equal to Q into R. Means if you will see here that what they did, the cross multiplication of these two rational numbers. So P into S is equal to Q into R. Then you can write P upon Q is equal to R upon S. Okay. Next is second one, P into S is greater than. Look, first sign they given is equal to, then the sign is greater, then greater than Q into R. Then you can write P upon Q is greater than R upon S. And now the last order relation, that is P into S is less than Q into R. Then you can say that P upon Q is less than R upon S. This is the order relation of rational numbers. Now, let us learn the properties of rational numbers. Okay. Here A, B, C are rational numbers. Then rational numbers, they should be in the form of m upon n, or numerator upon denominator. Now first of all we will see the property, that is commutative property of rational numbers. Now I will tell you here. First property, these properties are based on addition as well as multiplication. Now commutative, then associative, then identity, and then inverse. First we will see addition property, that is a plus b is equal to b plus a. Suppose we will take any number, any rational number. Means I will take the rational number here 1 upon 3. Plus I want to add 4 upon 5. This is our a and this value is b. So I can write it 4 upon 5 plus 1 upon 3. Just I changed the place. Okay. But the value of these two remain equal. Now next we will see the multiplicative property. Commutative only. Then in that, look, addition is a plus b is equal to b plus a. Now we will see the multiplication, that is a into b is equal to b into a. Suppose I will take a adds 2 upon 3 and b I will take 7 upon 5. Is equal to 7 upon 5 into 2 upon 3. Why they are equal? If you will multiply, then you will get the same answers. That is, the answer of this is 7 2s are 14 upon 15 is equal to, here also you got 14 upon 15. Okay. Do you understand this commutative property? Now we will go to next property, that is associative property. Okay, associative property for addition we will see. A plus b plus c is equal to a plus in bracket b plus c. Suppose we will take a and b as 1 upon 5 plus 7 upon 5. First we will write these in bracket, plus c as 8 upon 5. Now what is the answer of this? We'll see here. Here denominator is equal. So 7 plus 1 8. 8 upon 5 plus 8 upon 5. Means you will get the answer 16 upon 5. Okay. Now just what we have to do. We will first add this b plus c. First we are adding the bracket. So 8 plus 7 means 15. So 15 upon 5 plus this 1 upon 5. Again you will get the same answer, that is 16 upon 5. So the associative property for addition is, in the bracket a plus b bracket complete plus c is equal to a plus in bracket b plus c. We have proved this property. Now we will see next property for multiplication, that is a into b into c is equal to a into b into c. Same way this answer it will also come equal only. You can see that by taking the numbers. Okay. Now we will see the identity property for addition. Any number, if you will add with 0 and 0 plus any number, then you will get that same number. Suppose I will take here 7 upon 9 plus 0 is equal to 0 plus 7 upon 9. means here answer will come 7 upon 9 only. Okay, this is the property for addition. Now we will see the multiplication property. Multiplication property, in that property, what is given there? A into 1 is equal to 1 into a is equal to a, means any number will multiply by 1. 2 upon 3 multiplied by 1. What is your answer? 2 upon 3. And 1 multiplied by 2 upon 3. What is your answer? 2 upon 3 only. That only property they given here. Now inverse. You have studied this inverse in previous classes. What is the inverse of positive number? Negative number. And negative numbers, positive number. Addition we will see. Additive inverse means, okay, if you will add the positive number and the negative number, what will you get? The addition of positive and negative number, it is always 0. Positive and negative same number, this keep in mind. Here suppose we will take the number 4 upon 5 plus negative 4 upon 5. Okay, now plus minus means minus. So 4 upon 5 minus 4 upon 5. What is your answer? 4 minus 4, 0. 0 upon 5 means 0. Do you understand this? Now we will see the multiplication property. Look, multiplicative inverse. Number and its product of its multiplicative inverse. It should be 1. Okay. So here if we will take the number 11 upon 13 multiplied by, what is the multiplicative inverse of 11 upon 13? It's 13 upon 11. Here 13 13, 13 ones are 11 ones are 11 ones are. So your answer is 1 upon 1 means 1. Okay, here just only which condition is there? A should not be 0, because a will be 0, then any number multiplied by 0, answer will come 0, and this is not the multiplicative inverse. So we had seen the properties. These are commutative property, associative property, identity and inverse for addition and multiplication. Now let us recall. Decimal form of any rational number is either terminating or non-terminating recurring type. Terminating means the process stops. Okay, means there you are getting 0 as a remainder. Okay, and non-terminating recurring type means the remainder should not be 0. You will get again same numbers or different number again and again. So we will see here the examples. If you will see the first example, 2 upon 5. Just I will give here 2 upon 5 means what you are doing? 5 is in the place of denominator, 2 in numerator. Now 0 point. Look how that 0.4 came. 5 4s are 20. Okay, so your answer is 0.4. They had given. Now here the process stopped. So this is which type? Terminating type. Okay, next negative 7 upon 64. The process stopped when the your answer it comes negative 0.109375 and 101 upon 8, that answer is 12.625. If you will solve another example such as 17 upon 36, 33 upon 26 and 56 upon 37, then you will get in first example 17 upon 36, the number 2 occurs again and again. So it is non-terminating recurring type. Okay, so the same number occurs, so we are writing the point on the head of that number. Now next to that, if group will be repeated again and again, then we are giving line on the number. Okay, then here 33 upon 26 is equal to 1.269230. Again the same group 692307 repeated. So here this type is known as non-terminating recurring type. And the last example they given, that is 56 upon 37. Here the group 513, it occurs again and again. So the answer of this is 1.513, and upside they showed the line. Okay. Now we will see how to express the recurring decimal in P upon Q form. You know that P upon Q form, this form is known as the form of rational numbers. Now we will see one example solved in your book. Express the recurring decimal 0.777 and so on in P upon Q form. Here just see how to solve the example. First we have to take the value x. X is equal to 0.777 recurring. So 7 is recurring. So we have to write point on the head of the 7. So we had written here 0.7. Now if you will multiply x by 10, then right side also you have to multiply by 10. So when will you multiply? 0.777 so on multiplied by 10, then you will get the answer 7.777 and so on, means 7.7 recurring. Okay, now 10x minus x means 9x. Okay, and here 7.7 minus 0.7, what is the answer? The answer is 7.0 is equal to 7. So here the answer is 9x is equal to 7. So what is the value of x? X is equal to 7 upon 9. So we had expressed the recurring decimal 0.777 and so on in the form of P upon Q, that is 7 upon 9. Okay. Now we will see one more example. Just I will take in place of 7, I will take the number 0.555 recurring. We have to express this number in the form of P upon Q. Now here we will take x is equal to 0.555 and so on, means 0.5 upside dot will be there because 5 is recurring here. Now 10x is equal to 0.5 multiplied by 10, so you will get 5.5 recurring. Now 10x minus x is equal to 5.5 minus 0.5. So 9x is equal to 5. Therefore x is equal to 5 upon 9. Okay, means we expressed the recurring decimal 0.555 in the form of P upon Q, that is 5 upon 9. Now we will see the next example. Express the recurring decimal 7.529 and so on in P upon Q form. Again same thing we have to do. Now here x is equal to 7.529 so on. Here which group is repeated here? If you will see, the group of 5 to 9 is repeated. So this number means 7.529. We can write as 7,529 upon 1000. So we have to take here 1000x. If you will multiply 7.529 recurring by 1000, then you will get the answer 7529.529 recurring. Now we will subtract x from both the sides of equation. Then you will get here 1000x minus x is equal to 7529.529 recurring minus 7.529 recurring. So 7529 minus 7, you will get 7522. Okay, and this 529 and 529, 0.529, 0.529, it will cancel with each other. Now 999x is equal to 7522. So x is equal to 7522 upon 9999. Okay, so this 7.529 recurring we expressed as 7522 upon 999. Now just we'll see, remember this. Note the number of recurring digits after decimal point in the given rational number. Accordingly, multiplying it by 10, 100 and 1000. For example, in 2.3 recurring, digit 3 is the only recurring digit after decimal point. Hence, to convert 2.3 recurring in P upon Q form, multiply 2.3 recurring by 10. Okay, same thing we had done in the first example. Here they given 0.777 means here 0.7, so we had taken 10x. Okay, then the next example, there 7.529, so we had taken here 1000. Okay, now in 1.24 recurring, digits 2 and 4 both are recurring, therefore multiply 1.24 means this group 24 is repeating again and again, so it is recurring. So we have to multiply 1.24 recurring by 100. Now in 1.513, if you will see, the digits 5, 1 and 3 are recurring. So multiply 1.513 by 1000. Notice the prime factors of the denominators of a rational number. If the prime factors are 2 or 5, only then its decimal expansion is terminating. If the prime factors are other than 2 or 5, also then its decimal expansion is non-terminating and recurring. So by using this information, you have to solve practice set 2.1. Be safe at your home. Thank you. Bye.